In this video, I want to take a look at an introduction to probability distributions. So to begin with here, let's take a look at random variables. So a random variable is a variable where the value is dependent on the outcome of a random event. So what do we define as random here? Well, we say that a variable is random if the outcome is unknown until the experiment is carried out. So in that case then, if we want an example here, think about rolling a fair dice. So the score that we get when a fair dice is rolled would be an example then of a random variable. Okay, we don't know the score we're going to get until we perform the experiment. Now, the variable is also discrete if it can only take certain values. And then finally, what we say here is the range of values that a random variable can take is the sample space. So in terms of the notation here to represent random variables, we use capital letters. So typically what you'll see here is capital X. Okay, that's my random variable here. Okay, and if the random variable X here represents the score when a fair dice is rolled, then we can define a probability mass function. Okay, so for the probability mass function, I'll just write this out in full. So the probability mass function here, which you will often see abbreviated to be EMF. Well, in this case then, the probability mass function here would be the probability of our random variable here, x, being equal to a particular value of x here, little x. Well, the probability here of a fair dice, so the score that we get when a fair dice is rolled, that probability, if it's fair, will be 1 over 6. Okay? So the particular values we can take here for this random variable, in this case, will be little x equal to 1, 2, 3, 4, 5, and 6. Okay, so those are the particular values that we can get here for our random variable x. Okay, now we can also present this in a table. So if we present this in a table here, we'd have the particular values that we can take and the respective probability here for our random variable. Okay, so obviously the particular values I can take are these 6 values here. 1, 2, 3, 4, 5, and 6. What I would recommend is using a ruler. Don't do it freehand like I'm doing here. To make yours look a little bit neater than mine. Okay. Then obviously for these respective particular values here, then the respective probability will always be 1 over 6. Okay, so 1 over 6, 1 over 6, 1 over 6, 1 over 6 again, one more or 2 more times, and finally the last time there. Okay, so if I just close my table off here, we get something that looks like that. Okay, so what can we notice here? Well, for a random variable, in this case for our random variable x, what you should hopefully notice then is the sum of the probabilities here will add to 1. Okay, that might sound obvious, but it is a key fact here. So the sum of the probabilities here is equal to 1 for all particular values of x. Okay, that is important. And if I just finally give the definition then of our probability distribution, we say that the probability distribution fully describes the probability of any outcome in a sample space. Okay, so what we've got here, this here, what we call our probability distribution. Okay, so we'll just write this out in full. Like we said, that's our probability distribution there. Okay, and just one more thing here before we finish then. This here is a special type of discrete random variable. This is a uniform discrete random variable. This is uniform because each outcome here, each probability is equally likely. Okay, so if the probabilities are equal like this, that would be a uniform random variable. Okay, so that's everything we need there for our introduction to probability distributions. What we're going to do now is take a look at some practice questions. So if we begin with question 1 here, then we've got the random variable x, which has a probability function given as we can see here. So for part A, we're asked to show that k is equal to 6 over 11. So to begin with here, what we should do is find the probability distribution in the form of a table. We've got x here, and then the probabilities for our random variable here, taking these values of x. So obviously the three values we can take here for little x are 1, 2, and 3. So 1, 2, and 3. So what I would recommend doing, like I said before, is do just use a ruler to make it look a little bit neater than I am. So when x is 1 here, we get k over 1, which is equal to k. When x is 2, we get k over 2 there, so a half k or k over 2. And then finally here, when x is 3, we get k over 3 or a third k. Okay. So what we know here is the sum of these probabilities should be equal to 1. So the sum of these probabilities here will be equal to 1. So k plus k over 2 plus k over 3 is equal to 1. We write that down here, k plus k over 2 plus k over 3, and that's equal to 1. Okay, what you can do here is factor the k out. I'm going to get k lots of 1 plus a half plus a third, and that's equal to 1 here. So 1 plus a half plus 1 over 3, that would give me 11 over 6. So what I'm going to get here is 11k over 6 is equal to 1. If I want to solve for k here, I just need to divide by 11 over 6, or just times through by 6 first, and then divide by 11. Either way, you'll get the same thing here. And you'll get that k is equal to 6 over 11. Okay, so that's part A done there. That's our solution. Hopefully nice and straightforward. So for part B then, we have to find the probability here of our random variable x being strictly greater than 2. Let me just write this down here. So the probability of our random variable x being strictly greater than 2, well, that means the only possible option we have here is when x is equal to 3. Okay, that's equal to the probability of our random variable x being equal to 3, which is k over 3, but we know that k is equal to 6 over 11. That's going to be 6 over 11 divided by 3. That's going to give me 6 over 33 there. Okay, because that's the same as 6 over 11 times 1 over 3, which would give us the 6 over 33 there. Okay, and there we have it. So that's our solution to C, and that gives us the solution there to question 1. And finally, if we take a look at the very last question here, we've got a random variable x which has probability distribution shown in this table below. So we've got three parts to this. Part A, we have to find the probability that x is equal to 1. So for this question, hopefully nice and straightforward, we are just using this table here to answer A, B, and C. So the probability that our random variable x here is equal to 1, well, that would just be this case here. Okay, so in that case, our probability here will simply be 0.1, and that's our solution to A. For B then, the probability of x here, or our random variable x being strictly greater than 3, the probability that x is strictly greater than 3. We've got two options here. We've got this one here, our probability of 0.35, and this one here, our probability of 0.05. So what we need to do here is just add those together. 0.35 plus 0.05. Add those together and we get 0.4 there. Okay, that's our solution to B. And then finally, the last part here, part C, we have to find the probability of our random variable x here being between 1 and 3 inclusive. Okay, so again, just using our probability distribution here given in this table. Well, between 1 and 3 inclusive, that would be this one here, and this one here. So add those three probabilities together, it's going to be 0.1 plus 0.2 plus 0.3. Well, 0.1 plus 0.2 is 0.3, plus another 0.3 there, that would give me 0.6 there. Okay, in that case, our probability here of x being between 1 and 3 inclusive is 0.6. And there we have it. So that gives us the solution to question 2, and that brings us to the end of this video on probability distributions. In the next video, we're going to take a look at the binomial distribution.